To you all, am I audible? Hi guys, am I audible? Can we have a quick check? The video, where's the video? Yes, there it is. Hello, hello, hello. Am I audible, guys? Let me check. Hello, 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 hello. Yes, I think we are live. Okay, it seems that we are live. It seems that we are live. Right? Can you please tell, guys, if I am audible? Hello, hello, hello. Hello. I'm not being able to see myself. That is the problem. Anyway, let's see. Hello. Hello. Yes. I'm audible, guys, now. Yes. Okay, perfect. Okay, got it. Now I can see your chats also. I can see your chats. So let me get started. Let me get started. Okay. So guys, this is my profile and these are the results of last 3 years. JEE 22, JEE 23, JEE 24. Right? So these are JEE results. We have 13 learners in top 100 now. 13 learners in top 100, which is a huge feat. And majority of them have studied for IOQM as well. So this means that IOQM is something which is must for JEE ranks, at least for JEE ranks, right? Okay. So this is my JEE batch. If you want to enroll for it, you can use the code PJ Live. The link is in the description. Okay. Yeah, I can see myself now in the screen also. So this is a Ramanujan batch. I am taking classes every Tuesday and Thursday. Every Tuesday and Thursday I am taking the classes in Ramanujan batch. So 805 learners, we had 805 selections in RMO. We have the target of 1000 now. This year we are going to do 1000 selections. That is a non-negotiable thing. You will also contribute in it. I am pretty sure of it, right? We'll crack it. I know. If you want to access the DPPs and the content related to me, you can go to this Telegram channel t.me/pjsir42. Okay. Right. Perfect. So now we are going to discuss HCF and LCM. HCF and LCM of two numbers. There are certain things which you should remember. This is the nomenclature for HCF and this is the nomenclature for LCM. Right? Right? And what we know is H into L is equals to A into B. A and B are natural numbers here. We can also call them positive integers, but this is how it is, right? And there are two important properties which you should remember. First, HCF obviously divides LCM. HCF obviously divides LCM. Second, HCF divides PA plus QB, where P and Q are integers, right? P and Q are integers. This is a very important property. But now we are going to use these two, HCF and LCM, to determine basically the solution of simultaneous congruence. The end result of today's lecture is what we call Chinese remainder theorem as well. We will be solving simultaneous congruences, right? So I am going to start with a very basic thing, right? Let us do some problems in HCF LCM first. Okay, HCF LCM first. Question number 1, right? Find minimum number which leaves which leaves 3 as remainder upon division by 7 and 8 as remainder upon division by 12. So this is the question. Find minimum number which leaves 3 as remainder upon division by 7 and 8 as remainder upon division by 12. Right? Please guide how to study from CT-PCM. First of all, see, like CT-PCM is a RMO book. So first of all, you have to acquire the skills required to study any such books. All the RMO and INMO books have prerequisites, right? Even if you are following Pathfinder Senior, which is of Vikas Tiwari sir, so you have to do it. You have to follow these lectures first, get to the IOQM level and then attempt those problems. Yes, Ansh, you are not eligible for IOQM. Dropper learners are not eligible for IOQM. They are, however, eligible for ISI. Yes, there can be some printing errors. There can be some printing errors. Okay, Chaitanya Singh is saying the answer is 31, sir. Let me check. Let me check the answer. So now, first of all, I will write it in terms of congruence, right? This n is leaving what remainder? 3 as remainder mod 7, right? Mod 7, it is leaving 3 as remainder. Similarly, it is leaving 8 as remainder mod 12. Now, do you see that 7 minus 3 is equal to 12 minus 8? This is something which you have to observe. All these properties are written in my book also, but you have to observe these. This 7 and these 3. So, like, see, like, you had this as a given number, this as a given number, this as a given number, this as a given number. You have to make sense of these numbers. This is called number sense. So, 7 and 3, 12 and 8, the difference are same, which means if I add 4, n plus 4 is actually congruent to 7, which is actually equal to 2 mod 7, right? Similarly, n plus 4 is congruent to 0 mod 12. Okay. So this says that n 7 and 12 divides n plus 4. Now, what is the minimum number? What is the minimum number which is divisible by two numbers? They are LCM. LCM means least common multiple, right? So these are certain applications of LCM and HCF. This is how we use them, right? 7 and 12. So what is this means? N plus 4 is 84, which is the LCM, and your n becomes 80. N becomes 80. Okay. Okay. I hope I am making sense. Please write done. If you have understood it, please write done. And also, if you are seeing the recordings, you can leave the comments. I am very much motivated by the comments which you leave. And literally, I read all the comments on Olympiad Corner. I do not read comments in my JEE videos, but I definitely read comments, because I believe that this is a very small and very amazing community that we have built over the years. In last 5 years, we have grown from 0 subscribers to 71K subscribers approximate. Right? And this is your hard work and obviously team effort of my team as well. I have been teaching on this channel consistently for last 5 years. This is I think this is a record in itself. Right? Okay. Perfect. 71K. And we are going to celebrate it. We are going to celebrate it. Can I prepare for ISI from your lectures in 1 year? Yes, you can do it. Okay. Now let's focus on one more problem. Let me give you one more problem of LCM and HCF. Right? this is a problem which is a repeat of which is repeat of another problem. But before that, actually, we should solve simultaneous congruence also. Let us solve simultaneous congruence. Right? Solve for x congruent to 2 mod 3, x congruent to 1 mod 5. Right? Right? Let's solve. Now, since many of you have not studied AP, it is actually equivalent to finding common terms in AP. How? Finding common terms in AP. Right? This is equivalent to finding common terms in AP. Right? X is congruent to 2 mod 3. Right? Let me give you a solution. You can pause the video and then you can solve it. If I write the solution of it, x is congruent to 2 mod 3. This means x satisfy this. It is 2, it is 5, it is 8, it is 11, it is 14, it is 17 and so on. Now, if you see x here, 1 mod 5 means 1, 6, 11, 16, 21, 26. If I write it, now let's see the beauty of it. Let's see the beauty of it. Can you see that 11 is the first common term? After that, you have to hop 5. 1, 2, 3, 4, 5. 5 in this because the common difference was 3. But you are actually finding the common term between this and this. Here the common difference is 5. What is common difference? Difference between the consecutive terms. Here common difference is 3. You are hopping 5 times here and you are hopping only 3 times here. Are you understanding the correlation? The common difference here was 3, but you are hopping 3 times here. The common difference here is 5. You are hopping 5 times here. Right? And your next term becomes 26. The difference is 15, which is not a coincidence. 15 is actually LCM of these two. The LCM of 3 and 5 is actually 15. Right? So your common terms, this is the common solution. Now, can I say that all these numbers are of the type 15q plus 11? And the way to write it is, the way to combine these congruences is this. You write x is congruent to 11 mod 50. Am I making sense to you guys? Am I making absolute sense? Anuj, I believe, gave the answer before I wrote. This is how you solve simultaneous congruence. You can write the heading simultaneous congruence. Simultaneous congruence. You can write this heading. You can write this heading. Sir, I finished class 9 maths and starting 10. I also finished all the available English lectures. So should I start Hindi lecture? Also bought your book today. Okay. This can be done by CRT. This is CRT. You are using CRT without actually naming it. And this is what I do every year. I do not like using Chinese, right? I'm teaching basically the theory Ansh. What is CRT? You don't have to remember. Believe me, you don't have to remember. For you, CRT should be cathode ray tube, right? Cathode ray tube. It is a chemistry concept. We do not use CRT in mathematics. Okay? Okay? Perfect. So should we solve next problem? If you can write done, then I can move on to the next topic. Next question rather. I want you to solve one of the problem for me. Right? Okay? Perfect. Question. Solve simultaneous congruence. x is congruent to 0 mod 3, x is congruent to 2 mod 5, x is congruent to 9 mod 11. Right? Let's solve this. Solve the simultaneous congruence. Right? See, if you are asked find the minimum natural number, then you get a IOQM question. If you are asked to find all the numbers, then you have to reply in congruence terms. Right? So see, like the answer is always x is congruent to something mod LCM of these three. So the LCM is 165. If you can see, LCM is 165. Okay, so you have to find this bracket. Sir, in your book it is done in some table form. How to reach IOQM level? See, like IOQM level is a very high level. First of all, it is above JEE Advanced, above JEE Main, which means you require a complete year of preparation. So Sarthak, ask yourself this question: have you diligently prepared for 1 year? Have you seen, even if you are a free learner, have you seen my 109 lectures of IOQM? Have you completely solved my book? If these two things are done, then you can say that, sir, I have achieved IOQM level. IOQM level is not an easy level to achieve. It is the path of champions. Every year I say this thing. It is the path of champions. Not everybody can walk on it. Siddesh, like by practice. So there are 100 odd problems of sequence and series in last 4 years. Sir, in your book it is done in some table form. So we'll do that. 165 Q plus 42. In which NCERT there is this topic? Get over NCERT. This is beyond NCERT. This is beyond JEE Main. This is beyond JEE Advanced. This is something which is very huge. Even if you want to know in which NCERT this is, it is not in NCERT. It is in a CBSE book called Applied Mathematics. I have written a book on Applied Mathematics also. It is for CUET. So in Applied Mathematics, you get the topic number theory. Right? Logarithm you have to study from my recorded lectures. You can find logarithm Prashant Jain. You will find the lectures. So x is congruent to dash mod 165. Let's see. X is congruent to dash mod 165. Okay. So if I write this, this is 3, 6, 9, 12, 15, so on. If I write this, I have got 2, 5, 2, 7, 12, so on. Now, the thing here is, if I want to combine these two, it is very simple. I just have to find the first one. I just have to find the first common term. And now the LCM will be the common difference. So, this is the term. I just have to add 15 in it. Right? Now, if I generate this sequence, it is 9, 20, 31, 42. Can you see 42 is the common term? 42 is the first common term. So 42, and then the LCM is 165. So simply you can write it as 42. Now the answer is 42. It is a complete coincidence, right? It was not intended to be 42. Okay. It has nothing to do with my AIR. It has nothing to do with my AIR. It is a general thing. You got it? You got it, guys? You got it? Sir, I am new to Maths Olympiad and I have been an average student but with passion. Where I can get started with Maths Olympiad? First of all, complete 9th and 10th NCERT. And after that, you can After that, you can actually follow these Olympiad lectures. If you have done it, then we can move on to the next lecture. We can move on to the next question, right? In the next question, you will know it. Theta Hackett. What is this here? What is this name? In the next question, you will understand it. In the next question, you will understand it. Now, we'll take a very brief detour and study Bézout lemma. What does Bézout lemma says? That if H is your HCF of A and B, then you can actually have P and Q, then PA plus QB equals H. There exist P and Q belongs to integer. Right? To understand it, let me give you an example. Can I say that HCF of 12 and let's just say 78 is 6, right? Right? I hope it is the HCF, yes, right? So what this statement is saying, that I can choose certain integers. This is P and this is Q, so that this equation is satisfied. This equation is satisfied. Am I making sense? Am I making sense? This is basically the statement of Bézout lemma. This is basically the statement of Bézout lemma, right? This helps in finding solution of indeterminate equations, indeterminate linear equations, linear equation in two variables, right? It helps in finding solution of indeterminate linear equation in two variables, right? How to do your book? It is like there's a video how to use IOQM book. You can see that video, neural network. You can see that video. Okay. Perfect. So I think we should really see the application of it. What do you think? Guys? Should we really see an application of this? Diophantine can be multi-degree, right? Indeterminate is something which is used for linear equations. Yes. Let's try and understand this thing. So, see, I am asked this question. Solve for integral PQ such that 37P plus 43Q equals 2. What an amazing problem. Can you solve it? Just give me one solution of it. Just find me any one pair. Any one pair would do. Any one pair you can tell me. Any single pair, I'm okay. Right? Any one solution. I dare you, I double dare you. So let me do it in commonsensical terms, right? If I have to use my brain, what I would do, what I would do, I would simply write it as this. Right? So that this is smaller. So that this becomes smaller. Right? And then I would assume P plus Q to be another variable x. And then this equation becomes 37x plus 6q equals 2. Now, if you see closely, see this, actually this number is this number, any one solution you can find. Now, since this is even, I can say that x will be even. X has to be even. So this is even, this is even. So this further reduces my equation. This gives me 37y plus 3q equals 1. This is manipulation. This is manipulation. And now you can clearly see, if I write y equals 1 and q equals minus 12, I am done. Am I making sense? And since my y is 2, my y is 1, this gives me x to be 2. Now, what was my x? P plus q was my x. Now, my x is 2 and q is minus 12. So, this gives me P equals 40. Hush! Am I making sense? Am I making sense? Am I making sense? This is how you do it. This is how you do it. This is how you do it. But it included a lot of number sense, right? We have used here that this is divisible by 2, this is divisible by 2, so this has to be divisible by 2. Then we combine these things. So it is more intuitive rather than methodical, right? If I want to study a method of it, then I'll have to do certain things. How x equals 2y? See, I told you that this is even, which means this has to be even. If this has to be even, 37 is odd, x has to be even. So I did put x equals 2y. Am I making sense? Am I making sense? Am I making sense, guys? Right? Let's get on with it. Let's get on with it now. Let's move on to the next problem. Let's move on to the next problem. Okay? Let's move on to the next problem. In fact, method 2. Now, my method 2 is actually application. So, what is the HCF of 43 and 37? It is 1. And how do I find it? 43 is 37 times 1 plus 6. Then I write 37 is 6 times 6 plus 1. This is how I do it. Okay. Now, according to Bézout lemma, there exists some P and some Q so that this becomes 1. Right? This is the statement of Bézout lemma. And the algorithm to find P1 and Q1 is actually Euclid division algorithm. It is called Euclid division algorithm. Now, if you see, I want 1 in my equation, I want 37 in my equation, I want 43 in my equation. I will use these two equations to eliminate these 6, this 6, right? What is the value of 6 here? If you can see, 37 minus 1 upon 6. From this equation, I have written it, right? If I use this 6 and I put here, what do I get? 43 equals 37 plus 37 minus 1 upon 6, right? If I multiply it with 6, I get this. Okay, so 1 equals 37 times 7 minus 43 times 6. If I multiply to both sides, I get 2, 37 into 14 plus 43 into minus 12. Did I get the same answer? Did I get the exact same answer? 14 and minus 12 was my answer, if you remember. This is the method. While last method used a lot of intelligence, this method used lot of hard work actually. It is a see, like if you do 3-5 problems of this type, you will be able to understand this. And the best part about this thing is, if you have one solution, this is the best part, right? This is the best part. Let me give you the best part. Let me give you the best part. This was the equation, right? And you have found one solution as 14 minus 12. If you add 43 here and you subtract 37 here, this will also be the solution as per our intermediate equation theorem, intermediate equation, right? This is how to do it, 57 minus 49, right? So, in fact, the general solution, if you see the general pattern here, general pattern, can I say that P is congruent to 14 mod 37, right? Right? In fact, if I do not use congruence, I will simply write P comma Q as this ordered pair, 43 Q plus 14 minus 12 minus 37 Q, right? You can simply put this equation here, and like this, not, I should not write, just write T here, where T belongs to real number. So this is the general solution. This is called general solution. What is it? 43T plus 14 minus 12 minus 37T. Okay. Okay. Sir, I have a question. I have been struggling with this. Please lend me your hand. Chaitanya. Sir, can we also use this pattern while calculating zeros for pair? Yes. But in pair of linear equation, you have two simultaneous equations. No. That is not indeterminate. Pre-college mathematics book enough. Yes, pre-college mathematics book is enough for RMO even. Right? You can do my book for IOQM. Okay. Okay. Sir, I am currently done, but thank you, Kartika. Kartika, where are you from? Kartika, where are you from? Yes, see, like why I have written that this is the general solution. Even if T is real number, this solution will hold. This will hold. AP sir, nice. So this is why I started these lectures in English, because when, see, like this is a very amazing story. I went to Vijayawada last year. And I found a boy who was solving my book. Right? He came to me. I introduced myself as National Outcomes Head of Unacademy. He did not know me. That is the beauty of it. He did not know me, but he was solving my book, right? And he asked me one question from that. I solved it obviously, and I told him that this solution is not efficient in the book. This is the more efficient solution. So he asked me, sir, how do you know that the solution is not efficient? Right? So I told him, because I have written this book. So that was the moment of awareness for me, that there are learners in South India who wants to study from me, who are following my books, because the books are in English. But since I do not have any lectures in English, they are not being able to follow me. right? Anyway, perfect. So this Wilson theorem problem, we like the next lecture is Wilson theorem only. So we'll do this in next lecture. You can save this question for next lecture. Okay. Perfect. Now what do I have here? What do I have here? Method 2. Yeah, method 2 I have done. Okay. Perfect. Now if you see properly, this was my question. X congruent to 0, X congruent to 2, X congruent to 9. Right? This was my original problem. Now how do I solve it using Bézout lemma? How do I solve it using Bézout lemma? Please try and understand. First of all, I combined it to get 15q. Right? What did I get? 15q plus I think 7, right? I think 7, right? 15q plus 7, yes. 15q plus 7 was the solution of this. Not 7, yeah. What am I doing? Plus 2, right? So 2 is 12. 15q plus 12. 15q plus 12 was the solution of this, right? If you remember, 15q plus 12 was the, right? 15q plus 12 was the solution. And can I write it as 11p plus 9? Now just imagine that I do not know how to solve the sequence and series thing. So now this x can be written as 11p plus 9 and 15q plus 12. So if I combine them, since these two x are equal, can I say my x is of the type 11p plus 9 equals 15q plus 12? So can I say that 11p minus 15q is 3? Okay. Okay. 11p minus 15q is 3. Now I will again use Bézout lemma. What is the LCM of 15? What is the HCF of 15 and 11? It is 1. Right? Actually, I can write this 4. I can write it as 4 times 3 minus 1. Right? So that I have 11, 1 and 15 here. Right? I wanted 3 here. Okay, not a problem. So this is 4. I'll substitute this value here. 15 times 11 times 1 plus 11 plus 1 upon 3. So 15 times 3 is equal to 11 times 4 plus 1. Okay. Okay. You can check it. Now how do I solve it? If I get 11 times 4 minus 15 times 3 minus 1, multiply it with minus 3. So you have 3 equals 11 times minus 12 plus minus 15 times, I have multiplied with minus 3, right? Minus 9. Okay. So simply I can write P to be minus 12 and Q to be minus 9. Right? If I put these values here, x equals minus 132 plus 9 is, what is minus 132 plus 9? Minus 132 plus 9 is 123, minus 123, right? Here also I got minus 123. Now, since negative remainder is not allowed, I have to add LCM in it. 165 is the LCM, you get 42 as answer. So while Bézout lemma is very great, you need to understand why we need to read it. Let's assume that we have this problem. This is a more elegant way to put this solution in a written format. Let's assume that this question comes in RMO. So I consider that this commonsensical way using AP, this commonsensical way using AP, this commonsensical way using AP is a better method while attempting IOQM level problems. But this is not elegant to write. You have to write formal solutions in RMO, right? You have to write RMO, in RMO and INMO, you have to write formal solutions. This is not formal. This is not formal, right? The formal solution is using Bézout lemma. This is how you do it. Can you write done here, please? Can you write done? Can you write done here, please? Right? Should I study binomial for number theory? Yes, binomial we have already taught, something of that sort, right? I think it is time to do one more problem. It is time to do one more problem. Okay? Okay. Find last two digits of 3 to the power 2024. Find last two digits of 3 to the power 2024. I'll just come. Hello, 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 hello. Am I audible? Am I audible? Am I audible? Yes, this is the mic. Okay. 81. Okay. 81 is something which learners are saying. Okay. Find last two digits of 3 to the power 2024. I'll do multiple methods, right, for it. Method number one. Method number one, right? Can I write it as 9 to the power 2024? Sorry. Can I write it as 9 to the power 1012? And I can write it as 1 minus 10 to the power 1012. Now let me give you the formula for it. In fact, actually we have not studied this. Binomial theorem, we should have studied binomial theorem first. So this includes binomial theorem, which will be dealt in next lecture, right? In the next lecture, we will deal with binomial theorem, right? Binomial theorem we will deal in the next lecture, right? So we'll simply leave it. So method 1 we cannot do. Now we'll do method 2. 9 to the power 1 is congruent to 1 mod 100 9 sorry 9 square is congruent to 81 mod 100. 9 to the power 3 is congruent to 29, right? 729. So what I am doing, I am simply multiplying 9. This becomes 61. This becomes 49. And then I see the pattern. See, 09, 29, 49, 81, 61, and then 41. Right? Can you see the pattern here? If I go through this pattern, my 9 to the power 8 is 21 and 9 to the power 10 finally is 01. This gives me 9 to the power 1010 congruent to 1 and 9 to the power 1012 congruent to 81. Am I making sense? Am I making sense here, please? Am I making sense here, guys? Am I making sense here? So this is one way to do it. Right? Now, are you excited about the third method through Bézout lemma? Are you excited about third method? Are you excited? Euler-Tauschent, you have done through Euler-Tauschent, is it? Euler-Tauschent, seriously. Perfect. Now, I am going to do it using method number 3. Let's do it using method number 3. See, if I write 3 to the power 2024, 3 to the power 2024 mod 25, then this simultaneous congruence will have answer mod 100 and this is going to be my answer. Am I making sense? Am I making sense, guys? This is going to be my answer. This is all this while I have been doing this. All this while I have been doing this. Right? All this while I have been doing this. Right? Correct? 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 Now, let's solve these two. Let's solve these two. Okay? I can see 3 to the power 3 is congruent to 1 mod 4. Oh no. In fact, 3 to the power 2 is congruent to 1 mod 4. So hence this is 1. Very simple. Now 3 to the power 3 is congruent to 2 mod 25. Okay. 3 to the power 4, 16. So we just have to increase the powers. 3 to the power 4 is 3 to the power 6 is 81, which is 6, right? 3 to the power 6 is not 81. Just a second. 3 to the power 6 is 4 mod 25. Right? We want to find 3 to the power 2024. Okay. So obviously we need to find 1 here somewhere. 729, 729, 6561. Okay. So 3 to the power 9 is congruent to 8. 3 to the power 18 is congruent to 64, which is nothing but 11. 64 is 14. And 3 to the power 20 is congruent to 9, 126, which is congruent to 1, right? So I got 3 to the power 20 congruent to 1 mod 125, right? We studied power jumping in the last lecture. This gives me 3 to the power 20 congruent to 1 mod 125. Oh, sorry, not 125, mod 25, right? We are finding mod 25. This gives me 3 to the power 24 is congruent to power 4, 81. 3 to the power 4 is congruent to 6 mod 81. Mod 25, my mistake, right? Okay. So this is the question now. Now, can I solve this? Of course I can. Right? So just write this AP. Right? And among these four, which is following this? 1 mod 4. This is 2 mod 4. This is 3 mod 4. This is 0 mod 4. This is 1 mod 4. So this is the minimum number, which is the answer. 81 is the answer. Am I making sense, guys? 81 is the answer. Right? Okay. Got it. This is perfecto. This is perfect. Right? 81. So this is how you find the last 2 digits. Right? When will you start teaching on the IOQM nights batch? I will not teach on IOQM nights batch. I don't know who told you that I will be teaching on IOQM nights batch. Have you ever seen, like you must have seen my photo. Have you ever seen me saying this thing that I will be teaching on IOQM nights? I never said this thing that I am going to teach in IOQM nights batch. I am going to teach in Ramanujan batch. Every Tuesday and Thursday I am teaching in Ramanujan batch. Right? I know, Chaitanya, I am saying this thing, but I did not commit, right? And anyway, you are getting here, everything you are getting here. You are studying live only, no? Okay. Now the next question. This is interesting. Find last 2 digits of 6 to the power 2025. And now we are going to study the shortcut of it. I am going to study shortcut for it. Now we are going to study shortcut of it. Right? Now we are going to study shortcut of it. Right? Let me give you the shortcut of it. First of all, for the shortcut, you need the last digit. You should know unit digit cyclicity. What do I mean by unit digit cyclicity? If you see, if I write 2 to the power n, right? If this is this is R, n is R mod 4. If R is 1, the unit digit is 2. If R is 2, unit digit is 4. If R is 3, unit digit is 8, 4, 6, right? This is unit digit cyclicity. If this is 3, 3, 9, 7, 1. If it is 4, 4, 6, 4, 6. If it is 5, 5 everywhere. If it is 6, 6 everywhere. If it is 7, 7, 9, 3, 1. If it is 8, 8, 4, 2, just a second, 6. If it is 9, 9, 1, 9, 1. Okay, this is the unit digit cyclicity. Now, this means if I talk about 6 to the power 1, can I say it is 6 mod 100? 6 to the power 2 is 36 mod 100. 6 to the power 3 is 16. 6 to the power 4 is 96. 6 to the power 5 is 76. 6 to the power 6 is 56. 6 to the power 7 is 36. Can you see the pattern? Unit digit remains the same. 3 minus 2, 9 minus 1 minus 2. Now 1 minus 2, you can say that just take the carry, right? If you subtract 11 minus 9, it becomes 2, right? 11 minus 2, it becomes 9, right? So 11 minus 2 is 9, 9 minus 2 7, 7 minus 2 5, right? So if you see the pattern here, now this is repeating. If you see the pattern here, can I say that 6 to the power 5q plus 2 is 36? 6 to the power 5q plus 3 is 16. 6 to the power 5q plus 4 is 96. 6 to the power 5q plus 5 or 5q is 76. This power is multiple of 5. This power is multiple of 5, if you see, right? So your answer will be 76. 76 is your answer. Okay, 76 is your answer. This is the repetition. This is the pattern. This is the pattern, right? So if you see properly, unit digit cyclicity is 4, right? Every digit is repeated after 4 times. It can be 2 also. For example, in this case it is 4, it is 2. In this example it is 2. In this example it is 4, 4, right? Here it is 1. Means in every power the unit digit is same. Similarly, if I talk about unit digit, last two digits have the cyclicity 20, right? Very important thing. Last two digits have cyclicity 20. You can note it down. You can note it down, guys. Last two digits have cyclicity 20. Okay. 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 Last two digits cyclicity is 20. So, sir, can you apply this shortcut or whatever you want to say to 3 to the power 2024? Let me apply. Now, if I talk about 3 to the power 2024, you'll see the pattern very, very initially. 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 27, 3 to the power 4 is 81. Now see properly. 3 to the power 5 is 243. So 43. Right? See properly. 3 to the power 6, 29. Right? You have to see pattern among these. 3 to the power 7 is 29 3s are 87. Right? Plus 6. 3 to the power 8 is congruent to 87 times 3 is 261. Right? See properly, right? Right? In fact, since I have told you that the cyclicity is 20, this means that 3 to the power 20q plus 4 is congruent to 81. And can you see that this number is 20q plus 4? So you have got the answer. You have got the answer. Everywhere cyclicity is 20. Everywhere cyclicity is 20. Okay, and obviously it has to do with Euler-Taussian function. Obviously it has to do with Euler-Taussian function. Right? Right? This is the question which is going to come this year. I'm pretty sure of it. I'm pretty sure of it. Okay. Find last 2 digits of this was RMO problem. 2 to the power of 1990. Can you do it, please? Can you do it? It should be a one step answer. It should be a one step answer. It should be a one step answer. (24). Sir, it is very simple. 2 to the power 10 is congruent to 24 and 1990 is 20q plus 10. This means this is going to be the answer. Have you done it like this? Have you done it like this? Have you done it like this? Isn't it fast? Isn't it fast? Tell me. This is fast, right? This is fast, right? So nobody talks about cyclicity of last 2 digits. Nobody talks about cyclicity of last 2 digits actually. Okay, perfect. Now please write factorials. So factorials are nothing but n factorial can be written as n into n minus. It is defined recursively n greater than equal to 1, right? For this is the one. So the basic definition is n factorial is n minus 1 and it stops at 1. So 1 factorial is obviously 1. If I put n equals 1 here, 1 factorial is equal to 1 times 0 factorial, which gives me 0 factorial as 1. Which gives me 0 factorial as 1. See, like this is a vacuous truth. This is called a vacuous truth. There are certain truths about identities. So 0 is additive identity, right? 0 is additive identity. There are very special things about 0, right? For example, 0 factorial is 1. It is so unintuitive. 0 is the only number which does not have any sign. It is neither negative nor positive. 0 is a number which is both purely real as well as purely imaginary. It has so amazing properties, and that is why it was found in India, right? Many special things are found in India. Okay. Okay. So 2 factorial is 2 into 1. Now, the next factorials, I'll simply multiply 3 in this. I'll simply multiply 4 in this. I'll simply multiply 5 in the above. 6 factorial is 720. You have to remember till 10 factorial. You have to remember till 10 factorial. Can you please write it down? Can you please write it down, guys? Guys. So this is the definition of factorial. Okay. This is the definition of factorial. This is how you define factorials. Right? Can you find this sum for me? One into 1 factorial, 2 into 2 factorial, 3 into 3 factorial, 4 into 4 factorial, 9 into 9 factorial. Can you please find this sum for me? Can you find this sum for me, guys? Guys, can you find this sum for me? Perfect. Now, can I say that this is r into r factorial? Now, can I write this r as r plus 1 minus 1 into r factorial? If I multiply this r plus 1 here, this becomes r plus 1 factorial minus r factorial. So this gives me 2 factorial minus 1 factorial, 3 factorial minus 2 factorial, 4 factorial minus 3 factorial, dot 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 till 10 factorial minus 9 factorial. If I add them, I see the cancellation happening like this. This becomes 10 factorial minus 1, which is equal to 3628800 minus 1, which is 3628799. Right? Right? This is the answer. This is sequence and series combined with number theory. This is a 2 marker for you all. And it is a problem of JEE Main. This was in JEE Main. This was asked in JEE Main. Right? 3628799 is the correct answer. right? Is this the correct answer? Is this the correct answer? Obviously, it is the correct answer. Now, what is, see, like, what is the sum of digits here? Can you tell me the sum of digits here? Can you tell me sum of digits here? Is it 43? Is it 43 or 44? 43 or 44? Is it 43 or 44? 25, 33, 44, I believe. Sum of digits is 44. Third to fourth step. 1, 2, 3. See, this is r times 1 to 9, right? So I have put in 1 here, then 2 here. This is r equals 1. This is r equals 2. So I am putting the values of r here. Okay. So in this problem, what can they ask you? Sum of digits. They can ask you sum of digits. Am I making sense, guys? Am I making sense? Okay. Perfect. Perfect. Right? So this is a brief concept about factorial. Then highest power of p dividing n factorial. Right? P is prime. P is prime. Right? So the formula is greatest integer of n times n upon p plus n upon p square. Right? Let me give you an example. Find highest power of find highest power of 3 dividing 50 factorial. This is the question asked in JEE Main 2025. So 50 upon 3 plus 50 upon 9 plus 50 upon 27. Very simple. 16 plus 5 plus 1, that is 22. 22. Okay. Okay. Thank you, Alpha Chestnut. Got it. 16 plus 50 plus 5 plus 22. Now this is the question. Find number of zeros at the end of 42 factorial. 42 factorial. What if p is not prime? Then it is not applicable. Then it is not applicable. We'll see. Done. 42 factorial. Now, here, one common mistake is this. 42 by 10. This gives me 4. This is not the correct answer. Right? It will not have 4 zeros because this is not prime. So, you can see that 42 factorial is 2 to the power m, 5 to the power n, and so on. Now, can you simply say with common sense that m is greater than n? And to make 10, you need as many 2 as there are 5. Right? So, can I say the answer will be n? Can you say that your answer will be n? Because if you have n powers of 5, you will definitely have n powers of 2. Every power of 2 and every power of 5 will merge and will give you 10. That is the number of zeros. This is Legendre's formula. This is called Legendre's formula. Right? So, this is how you cater. Composite numbers. Got it, Chaitanya? You were asking, sir, how do I find for composite number? This is how you find it. So, 9 is your correct answer. Okay? 9 is your correct answer. Okay, 9 is your correct answer. This is how you do it. Okay? Very simple. Perfect. Right? Legendre's formula. Then we have binomial theorem. Binomial theorem is very, very important. But see, like, we just need to find. For us, we need only the statement of it. We do not need anything else. And that too, we just need 1 plus x to the power n. This becomes 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2, 3 factorial x cube, and so on. Right? And so on. Right? So, with binomial theorem, can you give me 1 plus x to the power 4? This is all we need. Believe me, this is all we need. I will tell you why. Because we are after the remainder problems. So, we need only that much binomial which is essential for remainder problems. Rest of the binomial theorem we will study with combinatorics. It is part of permutation and combination. Okay? Yes. JEE 2028, the news is real. Just a second. So, this is 1 plus 4x plus 6x square plus 4x cube plus x to the power 4. Right? Now, I can find last 2 digits using binomial theorem as well. If you remember, this was my problem. I can write it as this. See, 9 and minus 9 to the power even and minus 9 to the power even are one and the same thing. Can I write it as like this? rest here, all the numbers will be divisible by 100. So this becomes 100q, and if you simply solve this number, you will get minus 90. Last two digits will be minus 90. And since your remainder cannot be negative, you just add 100 here to get 81. So this is how you do it. Okay. Can you note it down and write done? Can you note it down and write done here? Okay. Hello, hello, hello. Yes, this is the one. Hello, 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 hello. Okay. Done. So this is how you write, right? So this is the last problem of the day. This is the last problem of the day. In the next lecture, we are going to study invertibility, Wilson theorem and Fermat theorem. Okay, Wilson theorem, Fermat theorem, this is the part of next lecture. After that, we are going to do Chinese remainder theorem. After that, we will be doing base, what do I call it, base system. Then we will do greatest integer fraction part. One more lecture of number theory. In 9 lectures, basically number theory will get over. Meanwhile, you have to study geometry as well. Your algebra lectures will start soon. Okay. Okay. If you can find this answer, I'll be very, very happy. Now, my observation here is that this is 24 square. And 24 is 25 minus 1. Okay. Let's do it. Can I write this as 5 into 5 to the power 2024? Then can I write it as 25 2024, not 2024, 1012. Can I write it as 1 plus 24 to the power 1012? Now, if I expand it using binomial theorem, I can write it as plus 24 square, then something. This whole number is divisible by 576, which means my n is congruent to 5 times 1 plus 24 times 1012 mod 576. Now I will be more creative here. I can be more creative. I have 124 here. I have 124 here. Can I write it as 1008 plus 4? 1008 is divisible by 4. This is the beauty of it. 5 remains here. 1 remains here. 1008 times 24 is multiple of 576. We ignore it. And we get 4 here. So I get 97 times 5. What is 97? This is 97 times 5. 97 times 5 is 485. So 485 is my answer. 485 is my answer. This is a very advanced problem. Easily 3 marker. Easily 3 marker. Okay. Easily 3 marker. Do you agree that this has the potential to be a 3 marker? Do you agree that this has the potential to be a 3 marker? I think you would agree. You would agree. And this is very difficult to understand. That is why, see, like, I do not give much time in these lectures because anyway, all these problems will take 8 to 10 minutes to think on your own. First of all, you have to be comfortable with binomial. Then you have to be comfortable with calculations because I have done fast calculation here, right? So that is why each IOQM lecture should take 4 to 5 hours to understand. And that is why I am taking only one lecture per week. This is the reason why I take one lecture per week. Am I making sense, guys? I hope I am making sense. Right? Right? See, why did I remove 1008? So it was written as this, right? I wrote it as this. Then I wrote it as this. Right? What is 1008? It is 24 times 42. Right? It is 24 times 42. Okay. So if I write it as this becomes divisible by 576 and this goes into the modulus. This goes into the modular. This is divisible by 576. Hence, my answer is 5 times 97. Got it? Such a beautiful number, 1008, 24 into 42, right? 24 into 42. Perfect. So guys, that is it from my side today. See you next week. I hope you study well. Meanwhile, we are recording combinatorics lectures for you. We are also trying to record algebra lectures for you. And yeah, that's it. That's it from my side. Right? You can still join Nimbus batch. Today there is going to be one video about Nimbus batch, why you should join it. Join it using code PJLive. Try to take iconic subscription if you if you want notes like the printed notes. Okay, let's crack it.